Yes, I am here.
Excellent, excellent. Thank you so much. So Professor Halim Yanikomeroglu, who will be talking to us about the new non-terrestrial networks. Halim is a Chancellor's Professor at the Carleton University in Canada. So please, whenever you're ready, if you could share your screen. And there were already some questions about non-terrestrial networks. So this is just perfect timing.
Mona, do you see it in one slide at a time or two?
One slide at the moment.
Sure. So should I start then?
Yes, please, whenever you're ready. Thank you so much.
Well, it is such a delight to be part of this program, and I would like to thank Mona, yourself, and as well as Aryan and Mohammed for the invitation. In the next 20 minutes, 25 minutes, we will go through a forward-looking construct, and that is the non-terrestrial networks. This discussion is not new, but I will be saying different things, hopefully. Therefore, the title, New NTN Discussion. Well, this discussion is not confined to 6G, because 6G is around the corner from a long-term research perspective. For the first time, this discussion is becoming tangible with a solid framework, and it will continue, in my view, several decades without being an exaggeration. It's very interesting times, therefore. And when we say NTN, implicitly, we mean that we have an integrated overall one network with the terrestrial components as well. I will unpack that as we move forward. And when we say NTN, most people understand exclusively satellite networks. However, there is much more to that story, the lesser known parts in stratosphere. Therefore, I will focus mainly on the stratospheric component of non-terrestrial networks. And once you have such a network, actually, you can do much more than connectivity. Connectivity becomes one of the possible use cases. And furthermore, we should not tie NTN to rural and remote. That is as well a use case, but rural and remote is not where the activity, where the money is. NTN has things to offer, first and foremost, in the metro areas where the population is, where the industry is, where the money is. I will start by positioning NTN with respect to 6G. A very brief mention of satellite mega constellations. The previous presenter already mentioned about those, but I will focus on the less known component, high altitude platform station networks, and then we will move forward. Now, it is quite a common buzzword, 6G NTN. However, it has quite a bit of history, although we were not calling it NTN. But if you go to 90s, as soon as GSM became a success, people were talking about integrated GSM satellite networks. And every generation, we had that discussion without necessarily much success. But once again, now it is the time we are making that discussion in a tangible manner, and it is only the start. If you go to Google Images, as I did, and type 6G, so many nice view graphs come up, gigabit per second connectivity, and so on. But the reality is, in Canada, if I take the train from national capital Ottawa to the biggest city, Toronto, and mind you, this is a G8 country, just north of the US border, at least 1/3 of the tracks, I will not have any signal, let alone gigabit per second connectivity. I can't send an SMS signal to start with. So today, or when in the context of 6G, we are mentioning all these cool applications, augmented reality, and so on, but that happens only if you are close to the network. And network really does not exist in most of the land. 6G framework was established by ITU June earlier this year. Now this is the very famous one of the two diagrams that ITU came up with. On the below side in green colors, we show the incremental enhancements of 6G in comparison to 5G. So there are the usual KPIs like latency, like rate, and they get better. There is no surprise on that part. But the interesting part, something we are discussing for the very first time, is the upper part shown in blue. We are talking about now coverage, ubiquitous coverage. It is not sufficient anymore to have the network in big cities alone. You have to have coverage everywhere. And we are talking about sensing, sustainability, interoperability. All of them can be read as NTN. So NTN will be a very important paradigm, not only in 6G, but moving forward towards 2050s. Satellite mega constellations, we are all very fascinated. It was a bit of a shock in 2018-19 when we start hearing about Starlink. But I think everyone is fairly familiar about satellite mega constellations. Therefore, I will move right away to what is happening in stratosphere. According to ITU's definition, HAPS is a fixed object in stratosphere, 20 to 50 kilometers, but most of the activity is on the lower part of stratosphere, that is 20 kilometers. So it is some sort of aircraft at a fixed point relative to Earth. That is, it is not orbiting, unlike satellite networks. And then it basically provides connectivity and other services. In the diagram here, there are different types of aircrafts are shown. In the older days, balloon would be the rudimentary aircraft type, but not a very small balloon, maybe 60, 70 meters in height. Anyhow, the current and upcoming projects are very much aircraft design focused. There are gliders, zeppelins, and much more advanced blimps, if I may say. Also, uncrewed airplanes working with hydrogen fuel. All these are possibilities as aircraft type. And mind you, 20 kilometers is about the airline routes and about the inclement weather activities. So ITU's interest in HAPS is not a new story. As a matter of fact, since 1990s, ITU has been allocated dedicated spectrum for HAPS applications for rural and remote coverage. That's the bottom line. But that dedicated spectrum itself has been in many ways a roadblock for the development of HAPS due to the fact that when you have dedicated spectrum, you have dedicated equipment, dedicated air interface. Basically, this is a separate network than terrestrial network. Who wants to carry multiple devices? One for HAPS, another for satellite, another for terrestrial. It really did not take off, and it couldn't show its potential, this paradigm, mainly due to the fact that, again, it was envisioned historically as a standalone network for rural and remote coverage. We have to put aside that viewpoint. So in my group and with my collaborators, as a matter of fact, Professor Mohammed Zeeshan, Shakir, and I did some earlier work in this area a number of years ago. Our envisioning is that this is a multi-tier network, and stratosphere is just a native extension of the terrestrial network. So on the ground, you have small base stations, macro base stations, and then in the air, if I may say, or in the stratosphere, we have a super macro base station. That's a term I coined, and this integrated network I sometimes call in my publications as a vertical headnet. As we know, headnet refers to the multi-type of access points. In terrestrial networks, now we have a vertical heterogeneous network. How do we differentiate HAPS with respect to both terrestrial and satellite networks? First of all, in comparison to LEOs, which are about 500 kilometers above, HAPS is much closer, only 20 kilometers. And even LTE, air interface, allows communications with that distance. So direct to device is in many ways quite straightforward when we are talking about HAPS. It is non-orbiting, therefore you don't need to track anything. You don't need very complicated phase arrays on the user side. HAPS is huge. This diagram showing a Zeppelin is about 135 meters by 65 meters. Since it is huge, it can carry a lot of equipment, and you can do much more with them. For instance, cameras, in addition to connectivity. And this is first and foremost for urban and suburban regions, and it can be extended to rural and remote. In short, we are talking about an integrated terrestrial, non-terrestrial network in an harmonized spectrum, one air interface, one device, one network. That is the bottom line. Here is a view graph from one of my magazine papers in this area. Consider a city like Ottawa, where I am. In the skies, there is a HAPS or a HAPS cluster. If it is a cluster, they are connected to each other with super high rate laser inter-HAPS links. And then you can create different types of beams for hotspots, very narrow beams for wide area coverage, wide beams for users on the ground, for users in the air, like cargo drones, for backhauling of small cells. There was a question in the chat for the previous speaker. Without going much into detail, Zeeshan and I, and Mohammed Al-Zanat, a PhD student at the time, wrote a magazine paper about backhauling small cells on the ground with HAPS in 2018 or 19, Communications Magazine, and I got and that got the best paper award from IEEE. Now, imagine I have this infrastructure in stratosphere. Even more important than connectivity, it might be very helpful for surveillance, monitoring, sensing. Just imagine a time where cars do not have license plates in front and back, but on the rooftops, not necessarily seen by naked eye, but can be seen with infrared and other technologies. Any traffic infringement instantaneously can be detected. And now put atomic clocks here in the HAPS. Localization, positioning, navigation becomes centimeter accurate. Today, we use medium Earth orbit satellites at 20,000, 30,000 kilometers. Imagine what we can achieve at only 20 kilometers. And as a kind of continuation of the previous talk, this network can be very energy efficient because you wouldn't need to densify the terrestrial network unnecessarily. I can have many beams in stratosphere, and as the demand on the ground appear, those beams can be turned on and off. This is what I was mentioning. HAPS enables a centralized massive access capacity, and I can divert that capacity to wherever is needed and whenever is needed. So imagine here, this is showing in Ottawa, let us say, multiple HAPS beams. If I have IoT to devices to collect in a radius of 100 kilometers, I have this big beam. But if I have very narrow beams, I can create hotspots on the ground. Imagine this green thought as a connected autonomous tourist bus. 100 people, each person is a network. Collectively, it requires terabits per second connectivity in 2030s or 40s. Now, rather than densifying that suburban area so that this bus would always be close to an access point, that is not a good design. That is over-engineering. That is a lot of CapEx, a lot of OpEx, a lot of energy consumption. I can rather turn on a beam from HAPS, and as bus moves, that beam can track the load. So excellent for supply-demand matching in networks. Every generation offered about 2 orders of magnitude enhancement in aggregate capacity. Now in 6G, we are mentioning possibly up to terabits per second. Therefore, it is only a matter of time. We would be talking about 100 terabits per second in 7G times of 2040s. And this is doable with the HAPS. Why I am saying that? Because as we speak today, we have high throughput satellites like Viasat-3 at geo altitude, which has 1,000 beams, and in aggregate, they can offer terabits per second capacity. If we are able to do that from 35,000 kilometers, most likely we should be able to do that from 20 kilometers, actually much better, up to 100 terabits per second in 2040 timeframe. So in many ways, HAPS can utilize the very best technologies, both from terrestrial and satellite networks. Another view graph from some of my magazine papers in the skies of whether it is Glasgow or Ottawa, a cluster of HAPS, again tied to each other with laser links, and then they have different beam types. They are offering services for a variety of use cases, including backhauling whenever necessary. And that cluster is tied to, for instance, Montreal cluster, which is only 200 kilometers away, and also to the satellite network. This is an integrated architecture. It is much more than access. Here we are talking about backhaul, edge computing, which I didn't really have time to get into, transport, core functionalities. You can have functionalities of a data center in stratosphere. So it is, once again, more than communications. Probably the first applications might be in reconnaissance, surveillance, a lot to offer when it comes to sensing as well. I anticipate that by 2050, we will have somewhere between 10,000 to 100,000 HAPS globally providing service for all use cases. This is really transformative. And if we are thinking about the future smart cities and societies which are green and sustainable, there are really 3 enablers: sensors everywhere, on the ground, underground, in the air. Computing is through AI, and when the time comes, quantum. And then the architecture that connects all of them is this integrated terrestrial HAPS LEO architecture. It is a zero-touch network, 0-second setup time. Beams are on, off instantaneously.
Recording in progress.
And it is practically there is no outage. Just another example, let us say that in outskirts of Glasgow or Ottawa, there is a big concert, 50,000 people come together for an afternoon. Well, how can you provide service to that crowd? Don't worry. Our HAPS network is there. As you see, the beams can be turned on and off opportunistically and do the job. So the fact that we have a bird's eye line of sight view of a large area, and in that large area, I can divert the capacity wherever I want, is a big advantage. HAPS has a big surface area, I should mention. It is also very conducive for technologies like very advanced antenna architectures and also reconfigurable intelligent services. The bottom line is nothing is wasted. All the resources, whether it is computing, storage, antennas, they are centralized at a pool. And this has applications, so many. Imagine an autonomous and connected vehicle paradigm in a highway or in a extended city area. Rather than making handoffs continuously with the roadside units, at least the control channels can be moved to HAPS without any handoff. A vehicle can travel 100 kilometers. And really a nice example here, if you want to do construct the digital twin of Glasgow, why collect data from 500 small base stations? The HAPS can see the entire city in one shot. Very suitable application. So green, sustainable, future cities, HAPS is the way to go. And just to wrap up, I cannot think of a better example than the Saudi NEOM City, a $1 trillion project for 2030s and 40s. I got these view graphs from internet, but I put my HAPS. Without HAPS, it will be incomplete, this futuristic construct. I will actually skip the research directions at the interest of time. I have 20 slides for them at the very end as appendix. Just I will say a couple of words here. At Carleton University, we have a big team, also with our collaborators working on various aspects of this new paradigm, from antenna architectures to interference management, to propagation, sensing, navigation. Cybersecurity is obviously big. If that infrastructure is jeopardized, the consequences are really dire, and so on. I have to say that there are many challenges outside, let us say, connectivity paradigm or an extended connected paradigm, which are more related to aerospace industry, such as building a high endurance aircraft with high loitering time, but also energy. For 6G type of applications like a super macro base station, the 5G base station energy consumption or power rating is around 12 kilowatts. That can be done with energy from sun, with photovoltaic cells. But if you are talking about much bigger functionalities, then you would need more energy. And in that case, some more creative techniques will be necessary. I have quite many vision papers in this area. All of them are magazine papers, a dozen or more since 2021. A number of them are under review. You can check my website or this slide deck, and also more technical papers. For instance, our most recent work, as you see, some new antenna designs, advanced massive MIMO architectures for HAPS construct, or federated learning. Again, federated learning is very heavy on backhaul if you do that across small cells. But if you do that in one shot rather than in a hierarchical manner, it results in a lot of efficiency. I will leave these as well and just move to my final few slides. So what we are talking about here is not a single technology which would stay active for 5-6 years and then we will move on to something else. No, we are talking about a plethora of technologies, from physical layer to networking, and AI is a big enabler. Pretty much whatever technology you can think of in ICT, it will be an enabler in this new infrastructure, and the returns are unprecedented. Sometimes people find it a bit odd when you talk about a brand new network between terrestrial network and satellite network. But I ask, why not? We already have 5,000 plus satellites as we speak in only Starlink mega constellation. And if we can do this in space, I have reasons to think that we can do this much better in stratospheres. If you are interested, just type my name in YouTube. I have a YouTube channel with some cool videos. And if you would like to work in this area, here is my email. I would be happy to continue with the conversation. Let me end there. And based on the questions, I might show some of the backup slides on different research directions. Thank you, Mona.
Thank you very much. That was a brilliant talk. Great, great. So I'd like to thank you again for an amazing talk and for all the questions and answers. And I'd like to hand over to Zeeshan.
Well, thank you so much, Muna, and thank you so much, Professor Halim, for this very interesting talk.